Hello. Do you know why your morning coffee gets cold or your ice cream melts? Yes, we are not idiots. We know that it is because of the temperature of the environment. But do you know the exact mechanism that is taking place during those processes? We all learned that heat is transferred from hot object to cold object in high school. Let's dig a little deep to these processes and understand the basics of thermodynamics. Thermodynamics studies the transfer of energy. It specifically focuses on the relation between heat, work, temperature, and energy. As every beautiful concept that runs the universe, thermodynamics has some laws. First one says that energy can't be created or destroyed, it can only be converted. Let's give a boring example for that. Photosynthesis. Plants take the solar energy from sun and convert it to chemical energy. Great! No energy is lost, right? Wrong. No process occurs with a 100% efficiency. There would be an energy loss in every process, which can be considered as useless energy. This situation brings us to the concept of entropy, which is defined with the second law of thermodynamics. Second law says in every spontaneous process, entropy of the universe would increase. Entropy would deserve its own topic in a new video, but in most simple words, it is the energy that cannot be converted to work, which also aligns with the disorder term. This law also defines the direction of heat transfer. You know, the classic definition of heat moves from hot to cold. When you leave your coffee on the table, it would get cold because the room is hotter than the coffee. Entropy of the universe would increase in this process. Think of it like this. Little happy heat persons are in the coffee mug. They have order, certain places in this mug. When heat transfer begins, they begin to get out of the mug and disperse randomly in the room. Thus, the disorder of the environment increases. And whatever you do, you can't get those little happy heat persons back to the mug spontaneously. You'll need to find an energy source, oven, sun, or coffee machine, for example, to heat your coffee again. But the entropy of the universe would again increase. When you use 5 joules of energy per se to heat your coffee, only 4 joules would be transferred to the mug. Remaining 1 joule of energy would be lost and increase the entropy. We would like to remind that those numbers are just made up so that you understand the concept. As a result, you just wasted valuable energy and endangered the fate of universe by leaving your coffee mug on the table. Congratulations. Just kidding. The heat in your coffee won't save the universe. It would only increase your electricity bill a few nickels. However, the concept of entropy is indeed concerned with the death of universe, which will be the topic of another video sometime. For now, let's move with the third law. It says that a perfect crystal at the temperature of 0 Kelvin has 0 entropy. That's a boring one. I would give examples to this one, but it involves molecules and atoms, and nobody would like to hear about them. There is also a 0th law that nobody cares about. It says when 2 systems are in thermal equilibrium with a third system, which means their temperatures are the same, they would also be in equilibrium with each other. It is like saying that if you and your friend are in the same room with a third person, then you and your friend are also in the same room. What a shocker. That's pretty much it. Goodbye.